In this video, we're going to be building a 48 volt super simple emergency backup power system, and we're going to be building it around this awesome battery right here. This is a GRENERPOWER 51.2 volt, or basically 48 volt, 100 amp hour. That's all the way up to 5,120 watt hours of lithium iron phosphate storage. And like I said, we're going to make this very easy to start off with. Now I'm going to be using the same battery in a series of videos, and I'm going to be expanding upon it to add solar capabilities and other nifty stuff. So stay tuned to the channel. Go ahead and subscribe if you're not. But GRENERPOWER reached out and said, hey, would you like to check out some of our batteries? They've got a big line of different batteries, and I wanted to get a 48 volt tutorial out to you guys, so that's what we're going to be doing in this video. So thank you to GRENERPOWER for supplying this battery for this video review. We're going to be going over some of the specs on it, show you exactly what it can do. This thing is awesome. It came with some really neat documentation that I'll show to you also. But like with all my reviews, this is my review and it's going to be an honest review. No money is exchanged hands, and GRENERPOWER doesn't get to see the video before it's done and published. But thanks again to GRENERPOWER for sending this out. Hopefully this will help everybody understand how a 48 volt system can work and how easy it can be to start and how you can expand it out to grow. So I'm excited to get this video out to everybody. So without any further ado, let's get started. Hey everybody, it's Chris from FamilyGeekery, and today we're going to be building out a 48 volt system for emergency power storage. And we're just going to be using two parts to get this done. We'll explain all the different ways that you can do this, and like I said, we're going to be building out different varieties of this type of system with this battery. But I wanted to start very easy, very simple, to where if you just wanted to be able to store energy and then use it when you need it, maybe for a power outage or for a portable application, that's it. That's super simple, and that's where I wanted to start. If you wanted to get into charging it over solar and all kinds of stuff like that, we're going to build that out later. But I just wanted to start easy. Let's store some energy. Let's use that energy. And no better way to do it than a ginormous battery like this. And I've heard batteries called the heart of a solar system or the heart of an energy system. I think of it more of as a stomach, because the stomach stores a bunch of energy for our body, and it uses it when it needs to, and it stores it when it doesn't, and that's exactly what this battery is going to do for us. But before we get started into the project itself, let's kind of just look at this battery. Like I said, it came to us from GRENERPOWER, so I do want to showcase some of its features, and this is something that you could buy to upgrade your golf cart to a lithium system, or you can just use this for home storage, for emergency storage, for solar storage, any of the above. Now, it came with a cute little bag with some documentation in it and a service card to get your warranty started. And it also has just like a quick reference card here that has a bunch of information. And then it's got this really detailed product manual. And this has a lot of good information if you're just beginning with this stuff. It's got a lot of good information for learning exactly what this thing is, how to use it, how to know when it's charged, all that good stuff. And it's just a great manual. It's of course got all the specifications, but it also has in here a voltage chart for the state of charge. So if you just use a voltmeter, and we'll look at that just in a second, and see what the resting voltage is, you can get a approximate state of charge, what percentage charge it is. And then it's also got in here, wire sizes for different amounts of current that you're going to be drawing from this thing. A battery of this size can certainly produce a lot of power. It can produce a lot of current, and it's starting at 51.2 volts. So you can definitely power a lot of big stuff with this. But basically this book is pretty cool. A lot of good information. And it's also got Bluetooth built in here that you can see the state of charge and everything right from a phone. So we'll look at that also. But let's go over just a couple of the specs here just to see some of the highlights. We've got, like I said, a nominal voltage of 51.2 volts. The capacity is 100 amp hours of capacity. So you multiply those together to get this 5,120 watt hours of storage. That's how much storage you have in here. So when you charge it up, it's going to fill that up. And once you start using it, of course, it's going to take that down. But that is a lot of energy to store in there. It's got a 200 amp BMS. So when you're charging this thing and discharging from it, it's going to keep all those cells healthy and balanced. It's got a self-discharge rate. If it's just sitting here, it says less than 3% per month. So if you are just using this for emergency backup, you do want to kind of put it on the charger every, I don't know, 3 or 6 months, and just top it off just to make sure that it's staying up towards 100% and it's not depleting itself. You can connect up to 4 of these in parallel, so 4 parallel 1 series. So you can multiply this basically by 4 by putting 4 of these big batteries in parallel with each other. You'd have this 51.2 volts, 400 amp hours, so basically about 20 kilowatt hours of energy sitting there for you. And then some of the other specs as far as the current charge and discharge. It's got a standard current charge of 20 amps, a maximum continuous charge current of 100 amps, and about the same for the discharge, about 20 amps for a standard discharge, a maximum continuous discharge of 100 amps. So that would be about a little over 5,000 watts of power coming out of this thing, continuous, with a peak of up to 500 amps for 5 seconds. Now, hopefully you're not using that much power, but in case it does spike up like that, it's going to be able to handle it. And then it's got a bunch of protection circuits also for short circuit protection, low voltage, disconnect. You know, if you deplete this thing down too much, it's going to shut itself off so it doesn't hurt anything. And then once it charges back up, it's going to reconnect. So the first thing I want to do is I'm going to grab a voltmeter. We're going to check out the voltage on here, compare that up against the chart that I showed you in that book. And then we're going to pull up the app on a phone and look at the charge percentage on the phone and see how close they are. Now, before I take these protective caps off of the terminals and start playing around with them, I am going to be discussing real quick some of the precautions I'm going to be taking, because once you get up into this higher range of DC voltage, this 50 volts, then you do have to be concerned a tiny bit about having that kind of voltage go through your body. Now, as long as you're smart about it, there's really no concern, but like I said, we do want to take some precautions. Basically, we've got 51 volts here at this positive terminal, and we don't want that going through our body down to ground. So we don't want to lick our 2 fingers and stick it on the positive and the negative terminal. That would be bad. And we don't want to touch this positive terminal if we're not isolated from ground. So the precautions I'm going to be taking, of course, I've got shoes on. I've got rubber-soled shoes, so I'm not just standing barefoot on the ground. I'm going to be using some isolating gloves to give me some protection also from stopping that from going down to ground. And then, of course, I'm going to have some safety glasses on also. Now, not only do we not want this positive to go through our body down to ground, we don't want the positive to hit that negative terminal. So when I start using the wrench and stuff like that, you just got to be careful not to short these 2 out, because this kind of battery could provide a pretty large spark. So now that we got that safety precaution out of the way, let's go ahead and set up our test here and see how many volts we have sitting on this battery at resting. Alright, so these are not professional electrician's gloves or anything, but they are going to be sufficient for what we're doing here. And I know that because I tried to touch the touchscreen and it didn't work, so I know that they're somewhat insulated. So I've just got a standard DC voltmeter here, and I took the protective caps off of the terminals. Now, it came with 2 sets of these lugs, which is nice, just in case you lose one, I guess. So we got 2 sets of those. We'll install those in a little bit. But I'm just going to touch the negative to the negative, touch my positive to the positive, and then look on the little fluke meter there, and it's looking like 52.61 volts. So 52.6 volts. If we look at that on our chart here, that's right here at 52.6, and that is showing about 50%. So this came to me about 50% full. So the next thing I'm going to do is I'm going to fire up that iPhone app and see what it's telling me. Alright, so I've loaded the app. There's a QR code in the manual that you just download this app, and they must use the same Bluetooth chip for several of these batteries because it's not branded as a GRENERPOWER app. It's got some, ambiguous name, but it works just fine. And here it is. So this is showing the battery having a 48% state of charge. It shows the resting voltage here at 52.7, so pretty darn close to what I was measuring with the voltmeter. There's always going to be a little bit of difference. It shows all your cells here, it shows the temperatures, and it shows, how much current you're drawing and how much power is being drawn. So we'll go back and look at this again once we actually have something hooked up to this and we're either charging it or discharging from it. But a nice little simple app. That way you can have this in your house somewhere or wherever it is, and you can just connect to it over Bluetooth and see how your system's looking. So regardless of whatever kind of other fancy thing you hook up to this, maybe a charge controller or a fancy hybrid solar inverter or something that may have Bluetooth capability, you can just see that straight from the battery here, regardless of what it is that you've got hooked up to it. And I think that's great. So the next thing I want to do is talk about how we're going to turn this battery in an all-in-one emergency backup generator, if you will, with just one simple connection. So let me go grab our second device and I'll be right back. Alright, so in order to use this battery as emergency power, there's two things that you need. First, you need to charge it up. So it came to us 50% charged. We need to go ahead and get that all the way charged up so that we have this power waiting for us when we need it. So we need to charge it. And the second thing we need to do is have an inverter. And an inverter is going to take this DC power here and it's going to convert it into AC so that we can use it for household items. So maybe I just need to keep the refrigerator running, during a storm. I'm going to need something to plug that refrigerator or whatever device it is into something. And of course you can use a portable power station. I've reviewed a lot of those on this channel and they've got a lot of awesome features, but if you want just the absolute bang for the buck, then getting a big old battery and just a super simple connection to it is probably going to be the cheapest way to do it. So I said two things. We need a charger and we need an inverter. Now I wanted to keep this super easy for y'all. So what we're going to be doing in this video is using a charger inverter. So this is a DC House 1200 watt bidirectional inverter and charger, and this is specific to the 48 volts. So if you have one of these, they make these for 12 volts, they make them for 24 volts. In this case we're going 48 volts. And I'll go over all the specs for this one, but basically you're going to be able to use this, plug this into the battery, and then plug this into the wall, and we'll be able to use it as a charger so we can get this thing all the way charged up. And then when we need that power, we're going to unplug this from the wall, of course. This will still be plugged into the battery, and then you have AC outlets built into it. So AC input if you're charging to the battery, AC outputs if you're taking the battery, creating AC out of it, and then powering some device. And it really doesn't get any easier than that. Two connections to the battery, and then just simple household AC on this side. So let me grab the spec sheet for this so you know what to expect, because they make these, like I said, in different sizes, different voltages, different powers. But let's take a look at this one, which really was about the same price or cheaper than if I had bought a 48 volt charger and a 48 volt inverter. Usually it would be a lot more to have the convenience of an all-in-one package, but this one I got on sale at Amazon, and it was honestly cheaper than I could have got a decent charger and a decent inverter. So let's go over some of the highlights of the specs, and right here in the manual is a spec sheet. Rated power is 1200 watts. Peak power is 2400 watts. So with the 1200 watts, that's what you can expect to get out of this thing running full time. But if it surges up a little bit above that, then it's going to be able to handle that for a short period of time. It's a pure sine wave inverter. It outputs 120 volts at 60 hertz. The input voltage range is 42 to 58.4 volts. And it's got an inverter efficiency of over 90%. Now you're always going to lose something going from DC to AC, but 90%, that's pretty good. Now that's the inverter parameters. As far as the charging parameters go, you're going to insert AC, that's going to be right from our wall, and the AC charging power is a max of 800 watts. So it's basically going to be putting out the correct voltage for this to charge these lithium iron phosphate battery cells, and it's going to be able to create up to 800 watts going into here, which if we've got 5,000 watt hours total, if you deplete this thing all the way down, yeah, it's going to take several hours to charge up at 800 watts. But if I'm just topping this off, from 50% up, then, maybe 3 or 4 hours, we'll be able to top that off with this 800 watts of charging. Now included with this inverter charger is, of course, the AC cord here, which will let us charge. And then it comes with some DC cables here that we'll be able to attach this to this. Boom, we'll be done. So what I'm going to do next is I'm going to get this hooked up, and then we're going to be running some tests both on the charging of the battery and then discharging from the battery through the inverter to some device. So let me get this hooked up and I'll be right back. Alright, so I started off by taking the included cables here, which are 8 gauge wires, and according to the little chart that we had that came with the battery here, 8 gauge wires here are good for up to 50 amps, and 50 amps times this 50 volts, that'd be 2500 watts. So that's much more than this thing's going to be pulling. So it's nice that this particular device here came with the right size cables. If you're going to be pulling a lot more than this, if you're going to be pulling 4,000 watts from this battery, of course you're going to have much bigger cables. But that's one of the good things about these 48 volt batteries, is if this was a 12 volt system and we were going to be pulling this much power, you'd have much thicker much more expensive wires anyways. But I started off by just attaching this side to the inverter here itself, and you can see how the connection has this nice strong connection to this little bus here. And you do have exposed copper, of course, so that's why it came with these little protective covers. So once I had, the nut tightened down there, then you just pop this on top and you can just go finger tight with this little protection thing here. And now we are good to go, not going to accidentally touch anything. Now it's important to do this on this side first, because if I had attached it to the battery first and I had these things just sitting here, they could easily arc or short themselves out. So this is where now, once we're going to start making the connections, this is where we're going to put on the gloves, put on the goggles, and be a little bit more careful about what wire is touching what. And that's why I use a little extension here on this once I'm going to go tighten these things down, because if you don't use the extension and you're just tightening like this, you run the risk of shorting out the battery terminals. So let me get my gloves on, my glasses on, and get these cables hooked up, and then we'll have some fun with the inverter. Alright, so I got it all hooked up. I hooked up the negative terminal first, and when I hooked up the positive terminal, there's always a chance that you're going to get a large spark, because inside these inverters there are sometimes very large capacitors that need to be charged up before you make the connection, and there's several different ways of doing that. Just Google charge, like pre-charging capacitors. And I didn't think that this one would have that big of a spark. I didn't think this would have that big, that's usually the 2,000-3,000 watt inverters that have those huge capacitors. But I got a pretty decent spark out of it. But I think everything's going to be alright. So right now I've got this just hooked up, just two devices hooked up with the included cables. So what I'm going to do now is I'm going to hook up the charging cable, the AC input, into here, and basically use this bidirectional inverter charger as a charger. Now there is a switch on the left side here, but I think that switch is just to turn the inverter on. So I have not switched any switches on, and we've got a couple lights on the side here. And I've got a blinking light here, very simple operation. We've got a light that says charge, a light that says run, and a light that says fault. So it says it's charging. So let's go ahead and go back into that app and take a look at what it looks like. And just like that, it shows that we've got 13.65 amps going in there, 735 watts, and we're charging at 48%, and an estimated charge time of 3 hours and 42 minutes. So far so good. Very easy to hook up, very easy to know exactly what's happening, and now it's just a matter of letting it charge. So I'm going to let it charge for a little bit, and I'll go find a couple devices to test the inverter side. Now 1200 watts, just to let you know, is not necessarily going to cover everything in your house. If you think about a normal house outlet, just the one that's right on your wall, probably going to a 15 amp breaker in your panel, then that 15 amp at 120 volts is basically 1800 watts of power that can be supplied there. Now usually those things are daisy chained around the room, so you've got lamps and TVs and all kinds of things plugged in at the same time into that same circuit, and you've got several of those breakers going throughout the house. But just be mindful of whatever device that you do plug into this. 1200 watts is going to be the maximum continuous, which is going to be pretty good for the majority of household items. You're not obviously going to run your electric dryer off of this, but if you're in an emergency, this would definitely keep a lot of things powered up. So let me let this charge up for a little bit, and I'll be back. Alright, so I've got the battery charged up about 88% here, and then I unplugged the cable. So we're showing that it's got 53.88 volts and no current or no power because it's completely turned off. And now I want to test the output. So I've got enough juice in here now that I'm going to start using it. So again, don't have to change the cables or anything. We're just going to plug in a couple devices. I've got a little tiny space heater here and then a heat gun. So let's go ahead and plug those in. And now we've got the on-off switch here for the inverter. And now it's just going to start pulling DC power from the battery, converting it into AC power, and we've got a run light blinking now. So before we had a charge light, which meant that we were using this as a charger. Now it's running. I guess that means that it's being used as an inverter. So I've got the power sitting here ready to go. So let's go ahead and turn these on. So I got the space heater going, and I'm showing now a power of negative 573. So it's actually showing a negative. Before it was showing a positive. So that means that the power is coming out of the battery. And we've got an estimated runtime here of 8 hours and 24 minutes. So let's go ahead and turn on this heat gun also. So that's the first setting on the heat gun, got it up to 760. Let's go ahead and crank that up. And now we've got about 940 watts coming out. So we've got about 5 hours, a little over 5 hours of runtime available on this battery at this state of charge. And the battery cells look like they're sitting around 76 degrees. It'll be interesting to see if that goes up very much by drawing this much power out of here. And I know we got a lot of fans and noise going on right here. I apologize for that, but this thing right here itself is also going to kick on the fan if it hasn't already. Because once it gets above a certain temperature inside here, it knows to kick on the fan. But we are cranking, close to 1,000 watts out of this thing. And it's, of course, sitting rock solid because that's below the 1,200 watts that it's rated at. So I'm going to go ahead and let this sit here and draw some of this power out and just see if it has any problem with this 1,000 watts. I don't think it should, but I'll let it go ahead and sit and I'll be right back. Alright, so I ran these two devices here at 1,000, close to 1,000 watts for a little bit of time, and it didn't seem to have any problem at all. The temperature inside the cells here, or the temperature sensors inside the battery, didn't seem to go up very much at all, if any, so that's pretty good. Now obviously this thing is capable of a lot more power than 1,000 watts. We are definitely limited by this device right here in this scenario. And I've got this, let's go ahead and turn this off, and the fan will continue to go. Even though I have no power in it, it's still getting power from the battery. So it can continue to run this fan until it gets to the right temperature, and now it's just cut off. So the next thing I want to do is test something that the book for this device right here, the inverter charger, has a little, I guess, funky documentation on. So let me show you what I'm talking about. In the precautions for use, there is number 7 here that says, charging and inverting cannot be performed simultaneously. So that would tell me that, hey, you can't be charging the battery and drawing power out of the battery to run the inverter at the same time. But later on in the book, we've got these very clear examples of how to use this as a charger. Very simple, right? Hook the charger up to the battery, hook the charger into the wall, and it starts charging the battery. And then the next page, it has how to use this as an inverter. Hook the inverter up to the battery, plug something into it, turn it on, it's an inverter. But I've got this little paragraph right over here that says using the charging and inversion functions simultaneously. And it says when the inversion and charging functions are carried out simultaneously, the maximum charging power of the battery is 800 watts, which it already was, and the maximum inverter output is 400 watts. So that's well below what it's supposed to be able to do. But if the inverter output power exceeds 500 watts, so if you're drawing more than 400 watts or more than 500 watts, I guess, the battery will stop charging and supply power to the load instead with an output power of 1200 watts. So what that sounds like is maybe it is able to charge the battery at 800 watts and still use some of the power to run something small out of the inverter. And if you ask too much of it, it's just going to stop charging and just use the inverter. Now, I'm not sure why, if you've got this plugged into the wall and you're drawing out too much power, it wouldn't just go straight out. But let's go ahead and test this out. So I'm going to plug this in, get it charging at 800 watts, and then I'm going to pick one of these devices here to turn on. And I think I can turn this on the low speed to be under that 500 watts and see if it works as expected, and then I'll turn it up and draw out more than 500 watts. So let me get that set up. I'll be right back. Alright, so I've got the AC cable plugged back in. I've got the inverter turned off. I'm back charging at 716 watts. So I'm charging the battery up. So let's go ahead and turn on this inverter. And so far so good. The fan did kick on, and now we have the lights, both the charging light blinking and the run light solid. Now that's interesting. I remember in the book there is a chart for these lights here, and it shows the charging indicator. If it's green and flashing means it's charging. If it goes solid, it means it's fully charged. But on the operating indicator, or the run indicator, I guess. If it's always on, it means AC power supply. And if it's flashing, it means battery power supply. So I wonder really if it is taking from the wall 800 watts, sending it to the battery, and then it's got some power left to loop through to the AC output. And then once you exceed that, that's when it's going to turn off the charging circuit. So let's go ahead and test that out. So we've got a solid light here saying that whatever is plugged into here is running off of AC power. So I'll turn this space heater on. Now there's no indication from the battery itself that anything is happening, so it still just sees this as being charged. So that does prove to me that it has no idea that this thing is turned on. So I've got this turned on, and I'm guessing it's in the 300 to 400, maybe a little bit more than 400 watts right now because I've got it set on the high setting. So it must be coming straight from this AC circuit. The battery has no idea about it. So let's go ahead and turn on the second device here, which will definitely be more than 500 combined. And on the low setting, it's still handling it just fine. Let's go ahead and crank it up on the high setting. And now it looks like the power going to the battery has reduced some, but it still says it's coming from the wall. And I'm pretty sure I'm drawing more than 500 watts right now, but I'm not sure if these devices are actually getting the same amount of power that they were getting before. So let me get a power meter, and I'll be right back and we'll do some more testing. Alright, so I've normaled everything up as far as the charger goes. Now it's still charging at 700 and something watts. I've got the inverter turned on, I've got a power meter plugged into the inverter, and I've got a power strip plugged into that where I have these two devices. So now I can see exactly how much these devices are drawing. So let's go ahead and turn on the space heater. And we are right at 400 watts, and we are still doing exactly what we thought. We're still charging the battery, still running off the AC power. We get a solid green light on the run. Still finding 700 and something watts going to the battery. So let's go ahead and turn on this heat gun. There's 550 watts. And there is 680 watts, which again is not as much as the 900 watts that these two combined for before. So it must be reducing the power that's able to go out this port here, which these heating devices can handle that kind of reduction. They're just not going to heat as much. But we are definitely running over 600 watts, and it still says it's coming straight from the wall. And that does make sense, because if we've got, like I said, about 1800 watts available from the wall, and we're only sending 700 and something here, 600 and something here, that's only 1400 watts. So we still do have some room to grow. So I wonder what the limitation really is when the inverter knows to stop charging. And to be honest, I'm not super comfortable plugging more things into this to test that theory. So I think I'm just going to go with the theory that as long as you've got less than 500 watts coming out of the inverter, then you're just going to have pass-through power and still charge the battery at the full capacity of what they call 800, but we haven't really seen 800, but still pretty close. Alright, so I've performed all the tests I wanted to really perform. I've made a nice little mess out here of this. So let's go ahead and summarize some things up. And also, I'll give you some ideas of how, if you were going to have this set up full-time, or if you were going to have this set up ready to go, how I might kind of change things up a little bit, or modify it a little bit, just to make it kind of better for the long run. So the first thing I will say is, if you were going to hook this up and keep it hooked up full-time, I would go ahead and put a fuse, a battery terminal fuse, on the positive terminal here. And you can get these on Amazon. I'll get a link down in the description below. I didn't hook it up today because I knew I was going to be taking this apart to do some other configurations. And the book for the inverter charger doesn't really mention it, but it is a nice protection, more so for your battery than anything else, just in case this thing short circuits out. It's not going to destroy your battery, which in this case is the more expensive device on the table. So I would definitely do that. The other thing I might want to look into is maybe also putting a cutoff switch, disconnect switch in line with the power lead also, just in case you wanted to stop the DC power from going to this inverter for whatever reason. Or maybe even like a 50 amp Anderson plug to go between the battery itself and the inverter, so that you can swap out different batteries if you wanted to. So that would be another nice upgrade. And as far as if I can give some feedback to DC House, I would like to have a disconnect for the AC input without unplugging the cable. Maybe just a simple switch or a circuit breaker of some sort. You've got one for the inverter. I'd like to be able to keep this cable plugged in and just simply switch it off so that it's not charging the battery or trying to charge the battery when I don't want it to. Now also with that, I will mention that the instruction book for this says that you should have this thing grounded. Now of course when you have this plugged in, it's getting grounding from your house. But if you unplug this and have it set up just how I have it right now, then it's not necessarily grounded. So you may want to have this case grounded for the times that you don't have the AC cord plugged in. So I think I've accomplished what I set out to do. I demonstrated a simple way of hooking up a large battery to a convenient charger inverter to make an emergency backup system. You could keep this in the house, you could have it in an RV. Maybe you've already got this in your golf cart and you just need to pick up one of these and have the right cables to go between it so that if you had a power outage, you could go ahead and use the battery you already have and run some electronics in your house off of it. But like I said, the next step is going to be possibly adding solar so we don't have to rely just on the wall power itself to charge up that battery. So stay tuned to the channel, and once I get that set up, I'll love to show you how I got it done. But I think that's going to do it for this video. I hope you enjoyed it. I hope you got something out of it. If you did, I appreciate a thumbs up. Thanks again for GRENERPOWER for sending this battery to test out. I'll have some links below on where you can find these, and you can find these in different shapes and sizes and voltages. You can do the same setup. DC House makes these same things for different voltages, so if you want something smaller, maybe just a 12 volt 100 amp hour battery and then a smaller inverter, then that is also possible. So check out the description. I'll have links for all kinds of different configurations. And of course, if you have any questions about this, go ahead and drop it down in the comments below. I'll be happy to answer anything I can. But that's going to do it for this one. I thank you as always for watching, and until next time, peace out and geek out.